Hello everyone, and welcome to Application Assignment 5. So here we're going to continue concepts that we learned in the prep. So we'll begin with histogram. So here we have a histogram of women's shoe sizes. And women's shoe sizes are thought to be normally distributed with a mean of 8 and a standard deviation of 1.5. So if women's shoe sizes are normally distributed, we would expect 68% of women's shoe sizes to be with one standard deviation of the mean. So if you subtract 1.5, that would be down to 6.5 or up to 9.5. And 95% of women's shoe sizes to be within 2 standard deviations of the mean, which would be anywhere from a shoe size 5 on the low end, and then you add 2 standard deviations or 3, and to 11 on the upper end. A sample of women and their shoe sizes appears below. Complete the formulas, graph the result, and answer the questions. So, very similar to the prep, you'll calculate, always start out with the easy wins. So calculate the min value, the max, the mean, the median, the range, which is going to be the max minus the min, the standard deviation, and remember this is a sample, so it's standard deviation dot s for sample. And then you're going to calculate what net minus 1 standard deviation. So take the mean and subtract 1 standard deviation, take the mean, add 1 standard deviation here. And then you take the mean, add 2 standard deviations, subtract 2 standard deviations, take the mean, and add 2 standard deviations there. For the underflow and overflow values, you simply look at the chart. The chart has the underflow at 5.5 and the overflow at 11.5. So you just type those in, 5.5, 11.5. And then answer the questions. Is there support for the target? In other words, do the women's shoe sizes appear to be normally distributed according to a mean of 8 and a standard deviation of 1.5? And then you identify the graph type, and so forth. Okay, for the pivot, the pivot's actually an interesting one because you're going to go ahead again and do the min, the max. Notice here that for the pivot, we're not going to ask for the underflow and the overflow because those really only apply to the histogram, but we will do the mean and median, the range as max minus min, the standard deviation, and then we'll take the mean, subtract 1 standard deviation, add 1, take the mean, add 2 standard deviations, subtract 2 standard deviations, and then use the countifs function to find out how many values there are. And because because there's 100 records, that actually allows us to calculate and see whether or not these percentages were approximately met and whether or not we have support for the target. Then you make a pivot table. And this is really, really interesting because on the pivot table, you're going to group, obviously, the shoe size with an interval of 1 starting at shoe size 5. And what I want you to see on this pivot table is that it goes 5 to 6, then 6 to 7. And so the question is, who owns 6? If you go 5 to 6 and 6 to 7, which value contains 6? And we've used interval notation here. In fact, you should too when you name this column to show who owns it. So the square bracket means that the lower bound is included in this line, and the parentheses means the upper bound is not included, which means these are all shoe sizes 5, 5.5, but 6 is not included. Whereas here, 6 is included, 6.5, and then 7 is not included. You could also get that, even if we didn't put that interval notation, you could also get that just by looking at it because 6 can't be included in both. And if it appears in both, the only one that would make sense to be included in would be this one, right? Because if it was included in this one, then it wouldn't even appear in this one. So you can kind of use logic to solve that. But having said that, what I want to point out is that that's very different than the way the histogram worked. If you go back to the histogram, you'll notice that on the histogram, it's the lower bound that's not included and the upper bound that is included. So that's very different than what we're saying here, where it's the lower bound that's included, the upper bound is not. I don't know why Excel would have designed things that way, but it's the way it is. Okay, and then finally, we can solve the problem for ourselves so that there's no confusion when we make our own intervals, because we'll make our own intervals and we'll make everything included. So lower bound includes this number, the upper bound includes this number, but we won't have the numbers run into each other. We'll just go 0 to 5, shoe size 5.5, then we'll jump to 6 to 6.5, 7 to 7.5, etc., and we'll include both bounds. So there'll be no confusion. The stuff up top is going to be the same as in the pivot slide, and then you'll design a graph off of that. Now, why would you want to do any of this? The reason you want to do any of this is because if you were actually a shoe manufacturer or a shoe store and you're going to stock shoes, wouldn't you like to know how many of each shoe size to buy, right, to stock your store? And if shoe sizes are normally distributed, this gives you a very good idea. So for example, you really should stock your store with size 8 and then work down from there according to the graph. So and also size 7, sizes 7 and 8, those are going to be the hot shoe sizes, and then lesser so as you drift out to the periphery. So it's very useful information when you're selling things that vary under a normal distribution, to know how much of each item you should buy. So hope you enjoy this application assignment, and we'll see you next time.